So if you're going to be, if you want to look at any research on your supersid system, one is if you've got a supersid and you've got your computer that's tied into the internet, you can have it automatically record on this on the Space Weather Monitor's site. I've had mine, except until my antenna went down a couple days ago. I had mine recording full time, and you can look up the past history for almost the last 5 years when I've had my superset on. Why is this important? Is because one of the things that you can observe with this is, for example, eclipses. The 2017 eclipse, I was able to record I was in a great position to record the eclipse, the 2017 North American eclipse. We got another eclipse coming up. So if even if you don't have a supersid, you can go and look at a couple of the supersid locations and see if they pick up the eclipse. And it looks just like almost looks like a flare, but it's a more straightforward. Anyway, then we have the Radio Jove site, and you can, if you've got a Radio Jove set up and you're on the internet, you can tie in and start and record your data on Radio Jove archive. And same thing as you can look in the history of Jupiter events, and you know, find somebody with a Radio Jove that is a good output, and see if you can pick up, see if you can see some of the LNS events from Radio Jove in history. And so that's something that's fun to do. And you can also, if you have a Radio Jove, you know, be part of the archive. Okay, VLA data archives. There are the links. I'll get the links out probably on chat. And on this, basically the National Radio Astronomy Observatory has put out a standard archive interface that will allow you to look up, you know, you can see some of the inputs there, you know, observations that were done between certain dates, the frequency range that they were looking at. And why is that important? Because in radio astronomy and these interferometers, the frequency range is sort of looking at the molecular frequency that's trying to observe, just like we all do hydrogen at 1.4 gigahertz. There's certain, you know, certain things with like hydroxyl and things like that, so 1.6 gigahertz. There's various other molecular outputs you can observe, and you can actually look up the archives and just look for those observations. Coordinates, so you can actually look at a right ascension declination in the sky and a certain radius from that. Telescopes, let's see if I got that next one. Telescopes, I think they've got they got ALMA, they've got Green Bank, obviously VLA, and a few other ones that you can actually pick the telescope out with. You can actually pick out not only the ALMA, but the array configuration that it was using. So that's what I'm saying. If you got a different configuration, you know, if you're a VLA and you wanted to get high resolution, then maybe you go with the A or the D. I forget which one's which, and you can look at the, you know, a certain configuration, and you'll just sort those out. Also, if you have, you know, the project codes and stuff like that. One thing I do use these for is if you've got a paper from somebody who did a VLA or an ALMA observation, you can actually look it up here, and then you can go back and you can actually come up with the actual raw data that they used, they collected from the antenna itself, and then you can go process that yourself or just look at the detail yourself. I sort of use it in reverse. I actually look this stuff up. I say I want to go look up um, Jupiter observations with the VLA, and I look that up, and it'll tell me all the different papers that resulted from that observation, and that's very nice, because one is not all observations are equal. If there's not been a paper associated with an observation, I have found that if I downloaded those and tried to process them, they probably were not really good observations, or they're just junk data. They don't really sort out junk data from good data on here. So I got a lot of downloads I had that were not good. Because but when I started actually going by and looking and only doing archive data that somebody did a paper with, then those were all good data, because that's what, obviously they used them for the paper.
Can anybody download data, or did you have to get an NRO account?
Well, you get an account, but basically that's 5 minutes to get an account. They don't really, just log in and add a new account, and then they just want you to set up a password.
All right.
And then at that point you're good. What that also does for you, since you put in your stuff, is that when you log in and you select this stuff, it'll automatically send you an email with the link to download with the data that you requested to download. And so it does that automatically. So very handy to have on that. Here's an example of just doing a sort on this. I was looking for actually masers with ALMA, because there's a lot of good maser talk going on with in the listserv. So ALMA has a ton of maser observations that were done, and so anybody is interested in masers and is doing, all the maser observations with their amateur stuff, they can actually go in and look at what the big interferometers did with the same maser and just compare them. So that's sort of fun. Let's see, what's this? Example of, I think, how to, when you select something. This is if you actually do you select something, it'll ask you for what type of output you want. So you can get calibrated, uncalibrated. You can get it in these SDM files, and so depending on what you're going to do with the data, you probably want calibrated data. Now, I was doing uncalibrated data because I was using those tutorials, and I was learning how to calibrate the data from scratch. But most people, unless you have a lot of time, don't have that. So what it'll do is they've got a pipeline that automatically calibrates the data, and then you can actually download the calibrated data, and then you can process it. So it's a little, you don't need as much skill to do the calibrations. You can look at it's not quite raw anymore. It's a better set. When we talk about calibration, we're talking about when you do an observation with one of these big arrays, you actually have to tell them your phase calibrator, your signal strength calibrator, which is a different object in the sky as a phase calibrator, and a couple other calibrators. And when you're doing the observation, the thing will automatically go to the source you're looking for, and then it'll take some observations with that. Then it'll actually go back to your phase and your signal strength calibrator and look at those, and then it'll go back. And so during maybe a 10-20 minute observations, it'll be looking at the phase and the gain, I'm going to call it gain calibrator, in between, so it can compare those things and basically calibrate your data to the Jansky level. So that's how that works. The ALMA has a different science link, which has a lot of other features that I like. It actually has this area over here, which will tell you the frequency bands that it's looking at. You can look up position, energy, project, publication. You can look it up by, the science. You have to enter your science data in there and say, okay, the science is, I'm going to look at supernovas, and you'll actually could do a sort by supernovas. So I really like the ALMA version of this, even more than the other one. And I was saying, and it also gives you a picture in the sky of where it's at. And I'm saying, here's some of that data, and then obviously down here, how old is the observation? What's the frequency? You can do all these sorts.
Is the ALMA data the same format as VLA?
Yes, the raw data is. It's MS files. By the way, all this, the CASA is all in Unix. So you download a .ms file, and the CASA picks up that file. So in that regard, is the CASA can process any of these data, and they're all yeah, with the exception of the antenna. You process them differently because they have different calibration inputs to them that you have to download separately, and it walks you through that. For one thing, ALMA, for example, has they're really concerned about the water vapor measurements, and the guys at the VLA are less concerned, so they have a different tool that does that, and so that's a different entry into the stuff. But the .ms files are the same format. That helps. This is an example of what you get is when your data's been. So all I have to do is hit that link, and I can go download the archive. This is where you'd find it. I just did you do a Bing search on NRAO data archives, and you can find that stuff. So you don't have to just find it. Let's see. This is some of the data requests. Now these files are huge. When I say that you may not need to have, here, and by the way, you don't need to download the archives and to do some of the processing. You don't need Unix. This is all this stuff was done in Windows, just for the download, to get in the archives. And some of the processing you need, if they're all calibrated, you don't need those. You don't need Unix. So there's a lot of Windows stuff that can go on. CASA right now, I believe, is only Unix. So I've got a separate Unix machine I process this stuff with when I do my own calibration. Let's see. And I wish I could get this. I don't know. The VLA has another interesting thing they're doing. They're doing a full sky survey, and they're taking a snapshot of different portions of the sky, and it's called NVAS. And what that's sort of cool is that you get these great VLA shots automatically processed that you can download and observe that little picture of the sky at a certain frequency, and they're doing it automatically. So you can get a lot of if you've got a part of the sky that you want to observe and maybe put your data in there too, you can download this. You can select the picture part of the sky you're interested in and download it, and then you can put yours in with it. Other nice thing to look at, and I know Steve Zekas and I were talking about doing a proposal together to actually do a proposal to use ALMA or the VLA and actually get an observation and get data for us. And that's something one of my goals is to get a proposal built. but there's a proposal finding tool. One of the inputs into the doing a proposal is, has it already been done before? Has what you're asking for already been done by somebody else? So this proposal finding tool is the resource that NRIO is providing to be able to look up any proposal that's been done in the past on any of the antennas to verify that you're not repeating somebody else's work. And by the way, if you find you are repeating it, maybe you can download their data and you don't have to do your observation yourself. So, but their goal is to sit there and try to make sure you got all the data and all the different, the knowledge of where all these downloads have been done or these observations have been done already. So this proposal finding tool is pretty cool. The other thing that does, by the way, is it gives you the science goal that one allowed them to do the proposal. When you do a proposal, one of the things you have to put in there for, by the way, you get to these, you can propose and get an observation with any of these antennas for free, but you have to go through, do a proposal, and part of that proposal is that you have a decent science objective that provides new science of some kind, and so if you go through these old proposals, you can see what everybody else put down to say, so you can maybe formulate something that you can come up with a science goal. Now the ATCA is the Australian telescope, and this is okay. So we're off the VLA and we're off the ALMA, and so this is the Australian stuff. Smaller antenna system, but they have a significantly good archive of their data with their interferometers. By the way, this is also where you find the pulsar data. They have a complete set of all the pulsar data, fully referenced. So if you want to find, the list of all the pulsars, known pulsars, this is where you'd go. Now, the other one I found was the European Very Large Baseline Interferometer. I'm saying we saw that picture, huge area observed. Very similar search tool, and you can find theirs, all their data. They also use CASA in theirs too, and they also have their own tools. So that's what you look for. Now, the other thing this has is a FITS finder. Now, we've talked about FITS before on the network here, and the FITS is, you can download some of these FITS files, and you can actually see the nice, beautiful picture of the sky you're looking at, and zoom in, zoom out, and it's all geolocated. So it basically has the right ascension declination embedded into the file. It's the metadata. So you can, when you add another FITS file on top of that, you can actually combine FITS files and overlay them. So that's what you would do. So some of the calibrated data you can get from the ALMA and the VLA data is straight FITS files that are fully processed from some of these things, and you just realize that they're gigabytes of data, but they're you can just download them and you don't have to process them. You can just use your FITS tool and look at them. So this one actually has a FITS finder for all their data, because it looks like they process it themselves too. Or I think you can actually do the .ms files and get and do CASA with these guys. They call it the European Baseline EVLBI network, and they have tutorials. I do highly recommend that you guys grab the tutorials from all these, the NRIO tutorials, the ALMA and you look at them. They even have a simulator. So if you think you want to go do a certain object in the sky, you can actually simulate it first. What it would look like if you put in X number of parameters in your proposal, then this thing will pump out what the resulting article might look like. And I think that's one of my next goals, is to figure out how to do the simulators. Easy download. I think you can actually use them in Windows, and this one also has a simulator. Well, it has tutorials. So you use the tutorials, and you learn the most with tutorials, and you get to process real data. And then as soon as you get the tutorials done, go get some real data, and do the same thing you did on the tutorial, but with a different data set. And that's sort of what I did here. And I'm just going to walk through these quick, because I do have this. This is something I did a couple of years ago. It is on the YouTube channel, my presentation on this. So I'm just sort of go through these couple, because just to see sort of the outputs you get. This is CASA outputs. And sort of what you look here is that there's a VLA observing log. This comes with the data set, tells you who the who the PI was, principal investigator, when it was observed, all the sort of the data for that. This is one of the outputs in the tutorial. This here, I just basically put, since I really didn't, a lot of this data, I didn't know what the object was, and I didn't know how close I was to, the VLA data, to an actual picture from somebody else. So what I did is I basically put, like a Wikipedia, here's what the 3C75 was, and then here's a different picture from a different observatory, so I can compare my result with somebody else's. So this is a real .ms set from the CASA that I processed, and I set my calibrations up, and you can actually see the polarization inputs here for magnetic field and right ascension declination. So this is that's an example of what you can do with an archive data download. This is a supernova remnant, and as I'm saying, I went over here and I tried to find an output from somebody else from a picture. I forget exactly what this one was. This is a carbon star. And I'm saying some of these things were part of the tutorial, so I chose them, but I'm still not really good with the actual astronomy part of this yet. So I'm better at actually producing the data than understanding what it means. Some of the hydrogen absorption lines. I think we've seen that in some of our hydrogen observations with art and stuff, that some of these objects actually, what happens is that you've got a hydrogen source, then you got something in between that's absorbing the hydrogen, and you get this dip in hydrogen levels. And the data will allow you to actually produce this plot of the raw data and observe the hydrogen absorption features on there. Cygnus A, we've looked at that before. That's actually, if you look there, there's actually the actual Cygnus A is right in the center, and these are the outflows of the data, or they're basically shooting the beams on both sides of the supernova. This is Titan. I didn't realize that you can actually see Titan, but they got a good view of Titan here. So I thought we can actually see, they mentioned you can't see anything but Jupiter. But I guess there's some parts of Titan you can see, and I'm not quite sure what's allowing it to happen. But you can there. This is a collision of two separate galaxies in the constellation of EVLBI. Now, the other thing you note here is that one thing I can do is I can put in different contours. I could select the contour range or signal strength, and it'll actually put the contours in for me, which is very nice because because this is a FITS file, I can actually measure this distance. Okay, now here's another thing. This is the beam size. So you look at that, that's the beam size is pretty large compared to that. And you'll see on these corners here, you'll see the beam size of the observation. Oh, by the way, this is the Janskis per beam. So obviously the higher, the more, the hotter it is, the more Janskis. I thought this was cool, a binary supermassive black hole using the EVLBI data. So binary supermassive black hole. So you got two black holes somewhere in here, and you're seeing both of them. Now, when you see the black holes, you can't see the black hole like you do the event horizon. You're basically seeing the accretion disk area. So I mean, you can almost tell by when you put the contours in that there's two objects here somehow, and you got hot in between, and then they start cooling off on the outside. A spectral line technique. Basically, you're looking at radio velocities, and they're looking at there's a closing jet, 850 kilometers per second. So you can actually see these, think of it as like Doppler, how fast these things are coming toward or away from us. I know it doesn't look like much here, but I guess this is the key. And you can pull that off the data. Those plots that's just another feature of the processing it. ATCA gave me a NGC 612, and just more good. I randomly picked that one out of the crowd. A 3C286 quasar. This was to look at the polarization capability. So the tutorial is actually how do you observe polarization on these, and so you can see the lines are the polarization. Right. And this is a nice thing is I found an article that had the same polarization stuff, so it looks really close. And he's noticed that on this right one, this is, I think, actually using, might even be the same data, but they processed it differently. They used different color bands and things like that, and they had different calibration sets. So it may, even if it's the same data, it's different. They process it different. And that's, I think, that some of the beauty of doing the archive data is that you can actually look at somebody else's work, but you have the raw data and you can calibrate it differently and maybe pull something out that they didn't. Okay, an Iris is a protostar. So it's sort of cool. I mean, these are just sort of these are actually these zoomed in. Juno asteroid, they actually observed that. So I was actually able to, this data, and then I just did a black and white version of that just to see what the contour bands were. So so you can see asteroids. HL Tauri. Now, what the cool thing I like about this is a protoplanet. So basically, you got a proto solar system. You got the central there, and then basically this is theoretically, that band there is a planet, and then maybe there's other planets around here that's causing these rings to happen. What this one is. Oh, this was not these moment maps are to help you find during an observation carbon monoxide and hydrocarbons. And then 3-2, 4-3 are the moments. I'm not 100% sure of what that actually does, but that's an important value in the chemistry. You can actually also pull up the actual graphs for those. So if you guys understand that stuff, you can use this to do that. Sagittarius A star. So this is what the ALMA sees when they look at Sagittarius A star, as opposed to the Event Horizon Telescope. So it's very, obviously you're seeing a little bit of it. The Event Horizon Telescope is probably, a little dot in that center there that they can zoom in on. So, but this was actually part of I don't know if this set of data was part of the Event Horizon Telescope data set. But if you combine this data with the data all the way around, you get this higher resolution. M100 is another spiral galaxy. I like this because you can actually see the spiral. It's really nice. You can actually see the spirals on the galaxy. And you can also see the radial velocity of the galaxy. You can actually, so what they're saying is you can actually see which direction the galaxy is spinning with this. Quasars. Same thing, you see the radial velocity on the quasar. This is sort of cool. This is a tidal disruption event. So, trust me, I don't know how you can tell it in there, but the experts theoretically tell that there is this black hole is eating a star or a planet or something. Tidal disruption is when one object gets closer to another object with a higher gravity, and actually the gravity that's holding the smaller object together is overcome by the gravity of the bigger object, and basically it disrupts their gravity. So they call it tidal disruption. So it just breaks it apart. There's a point when it's close enough to break apart the object coming in. Sunspots. You see where when they observe the sun, you can see the sunspots here. Betelgeuse. Now, Betelgeuse, the cool thing about Betelgeuse is that they were actually this little object down here. It could be an artifact, whatever, but theoretically, what they found with one of the reasons Betelgeuse was dimming was that they've got this big chunk of mass going in front of Betelgeuse. So this potentially could be that mass that we were actually seeing here. And one of the papers I actually did was to measure the distance here and see if I can, if this was even reasonable from a distance point of view, knowing the resolution and things like that. And it was reasonable. It wasn't speed, twice the speed of light or anything like that. So theoretically, if we looked at Betelgeuse a couple more times, and you might find that this blob is moving in relationship, and maybe is even related to the dimming that they were seeing in Betelgeuse. But so VLA could pick up Betelgeuse. So if we ever want to start observing Betelgeuse, see when it explodes, this would be a good thing to use. Another black hole, Cygnus X1. Really pretty observation here. So black hole somewhere in the center there. So we're really looking at the accretion disk of this. Cygnus X3, Q-type star binary. So I don't know where, somewhere in there is binary. So the expert astronomers have determined what these are. Another black hole or neutron star. Okay, so that's really what I've got. I'll show you a couple other slides here that I did, and I think you guys have seen these, so I'm not going to dwell on them. And this is from my advanced Excel, plugging Excel and using my hydrogen, the 9-foot dish in my backyard and a Spectre Cyber. I basically picked out the points and plotted them on Excel. So this is the right ascension declination of my hydrogen data. This is converting it to galactic coordinates. So you see that actually everything moves this way. And this is southern hemisphere, that little blob there, of no signal. The other thing is fun to do is to look up the radial velocity versus galactic longitude. And so I took that same data, and since I had the galactic longitude from that last plot, and I had picked out the highest data point I had for each of those data values and basically plotted them on this chart. And you can see how they follow the chart pretty nicely. And the nice thing about this plot and using your hydrogen data is that you can actually pick out some of the key things. Like this is the Perseus arm, and this is the Far Carina arm, and you can see that between here and here, your data set, you're looking at a different part of the galaxy. And here's a Cygnus area, and then there's so the outer arm, the Perseus arm here. So what I really like about this is that your hydrogen data can be used to pick out aspects on the Milky Way that you normally just can't. You just don't know. You don't know you're looking at it unless you plot it against this thing. A lot of the data you see from our experts that can plot, since I picked out the highest data point or the highest peak, and that's all you're seeing here. But if you actually do all of the entire signal strength and velocity, so you do the entire band, you can actually probably pull out this entire picture if you plot them all like this. So that's a goal potentially of this group is to do a real plot of this thing instead of just the data points I've got here. This is an example of the Perseus arm, and the black data is the data from my observations, so you can see where it's following it pretty nicely. Same with the molecular ring and the right arm. And also you always have to give credit to the NRAO. Whenever you publish some of this stuff, always put the caveats there that you use the ALMA data or the NRAO data for the various telescopes. Okay, let me get off of this. Okay, I was saying I repeated a bunch of this. It's also on the YouTube site and the journals. And by the way, the journal archive index is been updated for the last set of YouTube channels and journal entries. So if you go to the SARA website, and just to the right, you see the journal index. You can do a sort or for author, for keywords and things like that, or even for journal dates, and you can basically pull, figure out which journal and what page number each of these articles is on, and then you can just go to that journal and find it. So that's been updated. Let's see what else. Okay.
Question on the NRAO website.
Yeah.
They've got a tab there called SRDP, which they say stands for Science Ready Data Products. Are those the calibrated data sets you're talking about?
Um, I'm not sure.
It just says science ready, and the way it talks, it makes it sound like it's calibrated data. Like you say, you can either get calibrated or uncalibrated data.
Well, if you go to the archive data, they'll give you that option in the archive features.
Oh.
And this might be for the for the non-archivists that actually have the tools to process it. It's just like get here. When I do CASA, I can get calibrated data and start from that, or I get uncalibrated data, but I still have to run it through the CASA program. This might actually be that you just get the FITS files, and that's it. And so maybe it maybe really processed data that you just look at the pictures.
Okay. Yeah.
So right. Both are useful, I think, but that's probably what's going on.
Thanks.
So I have a question. When you showed us these different sites, and so you were moving around from one site to another, or you can, and do you have to have a login and credentials for each one of the sites, or do you have one NARO's credential set?
Well, the NRAO one, I think, works with ALMA. The the EVLBI and the ATCA are two separate ones too. So when you go there, their EVLBI and ATCA are definitely not NRAO. I log into either the ALMA or the NRAO, and they seem to allow me to move back and forth and keep my my login. And that's a good question, Bob. Did you do your presentation to that group yet? Is that coming up?
I did that last Wednesday night, and I felt like it went pretty well. And there were probably 15 people in the room and 15 people on Zoom. And these guys out at Palomar, California, are associated with, or they have a repeater site, and they have some connections, I guess, with the mountaintop that has the telescope, the 200-inch telescope on it. And they offered if we had anything we wanted to put up there in their so-called dark site and connect it in with their internet connection and repeater, that we could do it. So that was an interesting idea. Made me wonder about, well, maybe SARA should operate some remote telescopes in a few places and recruit some of these folks to help us keep them operating and running. But anyway, it was a good experience.
Great. Really appreciate you did that. Now the other thing, Bob sort of started this. One of the things we're going to start getting back to is going to some of these ARRL ham radio events, and you attended one in, I think, what, DC? Where was that?
In South Carolina. It was a TAPR ARRL digital meeting, and I made a couple of talks or a couple of little pitches there about some things that I'm doing related, like a meteor photographing.
One of the things and you guys need to sort of if you have the opportunity to present at one of these, one of the things I'm trying to get is a kit, sort of a presenter's kit that has a big sign for SARA. It has we'll get you brochures, we'll get you little cards, some stuff that will allow you to help present better, and set up a booth or something, or a table or something. Gary, were you or Dan gonna show something on the EME stuff, or?
I can. I think Dan wasn't there last month, so I could show something.
Okay, go ahead.
Okay. I have 3 items. I put together 3 items I can share with you. So I'll go ahead and share screen. Okay, and hi everybody. Let me just find the right screen. Bear with me for a second. Okay, first I'm going to share some photos. So Deep Space Exploration Society, we've been participating in the ARL EME contest. This is our third year. There are 3 sessions of this each fall. The first session is for higher frequency than what we use, so we do the second and third. I believe this was around October 12th. We did the second session. We operated at 1296 megahertz. It started that Saturday morning at midnight UTC and goes for 48 hours. And our local time when the moon rose was about 9:20 p.m. And it set like about a little after 1 p.m. the next morning. This photo is of our dish, our 60-foot dish, Saturday morning. Look, you can see pointed at the moon. This year, we were actually able to, I think, a little smarter. We did it in shifts so we could get some sleep. I worked with Paul NO0T. We did CW and Q65. We did mostly Q65. We only had did about 7 CW contacts for the full weekend. Let me just go through the slides and I can talk some more as we go through it. So this is Saturday morning, our group of cars, and we're in the trailer. That's where we're operating from. And behind you can see where the radio Jove antenna. I'll show you that in a little bit too. Another view of the dish looking at the moon. This is our setup inside the trailer. We had a large screen where we have on the right, which is our log. We were using an ICOM transceiver. We were using a Kier for CW, and let me go to the next photo. I'll just point out here though, we could verify our signal, our output, just make sure we were transmitting with the scope here. So we sometimes use that just to verify that we were putting out. This is a closer look at our setup. We were using the SJTX, I think, software for the Q65. It includes a little astronomy window that tells us the elevation and azimuth of the moon, and also gives us a Doppler shift between transmit and receive. And for this session, we were adjusting it manually, but for next session in this coming weekend, we figured out how to automatically have that feed our transceiver so we don't have to do anything and just let the transceiver do the work. But it's a feature of this program. This is a transceiver. We go to the next picture. This is just a close-up of our tracking computer. You can see that we're tracking on the moon here. This is our the beam width, and once we automatically set for tracking on the moon, it just follows it, which is great. Here's another view later in the morning when it was close to the moon was close to the horizon, but not quite yet, and you can see a close-up of the moon there. And when the moon is to the west, we're over the Pacific, and there are not as many hams that are active across the Pacific. So we kind of watch out for, we kind of do a look on the computer and look up what the times are for the moonrise in various places. So one of them was the Philippines. There's a ham out there, and we watched out for that, and we found him, and we made a CW contact. We made an earlier contact with Japan. Paul did that. And then just at the end, we got a few contacts with Russia, not just the Pacific side of Russia, but even deeper into European Russia. but we didn't get any contacts with Australia this time. We heard them, but they didn't hear us, or there was just a pileup, and so that didn't work out. This is just a view of our landscape. We're out in Kiowa County in southeast Colorado. It's all ranches and farmland around us. To just give you a sense of what it looks like out there. I took a photo of our radio Jove antenna. They're two phased dipoles. This is another view of our shack and our 60-foot dish. This is Paul. After the moon set, and he was configuring the software for this coming weekend. We had an SDR. We were trying to use that. It was a minor glitch in the power feed to that, so we didn't use it. Our backup was the ICOM. And this coming weekend, I think we're going to do 432. Maybe Dan may know what exactly we're going to use, either the SDR or another transceiver. But I think we're going to use another transceiver and use an inverter to just go from 6 meters to 432. I think that's our plan.
Yeah, I'm not sure. They're down there today. If the weather was good, they're going to try and switch feeds. So I'm not sure what the setup's going to be.
Okay. I want to point out this too. This is Bill Miller with Cindy McLeod. She had been a county commissioner for Kiowa County, and now let me just see if I can find the right file for this. Bear with me a second. Yeah, let me switch. Here we go. This is from our meeting minutes. This is Cindy McLeod with Ray Uberekin and me. Here you can see Cindy McLeod is now with the Kiowa County Economic Development Foundation, and she's looking to get the county designated as a dark sky site. And so she's looking for our cooperation. When it's dark, you do have a nice view of the Milky Way. It is quite a deep sky, and that would help them economically too, to try to attract at least tourists. So she's working on that, and she came to visit us. We've met her before. We've talked with her before at some of the local community events. It's a nice relationship, and she came out to visit us. There's one more thing I can share with you. Oh, yeah, let me go back here. This just some photos from the Friday afternoon when we changed the feed, the 1296 feed. This is Ray and Bill, and Glenn was taking the picture, and this is the amplifier that's put inside the feed here, which gave us 180 watts at the feed. Okay, and I'll share one more thing. This is our log, and just to give you a sense of, we had 47 contacts, 7 were Morse code CW, the rest were digital Q65. A lot of Europe, and I'll just scroll through that a little. Some USA and Canada. We had a couple South America. And this is over both nights. So if we're going to operate again this coming weekend with Veterans Day on Friday, probably we'll have a chance to rest a little bit more and maybe be a bit more active this time. I know I was quite tired the past session, and I was just there the first night, and Paul operated both nights, and also he had the support of Ray, and we had some visitors, local folks coming, including the mayor of Haswell, which was nice, with her son. So it's a good operation. This is our 3rd year doing it. 47 contacts on the first weekend. That's about comparable to what we did last year. say we're trying more things and we're getting better. This year we did a lot more Q65 digital. With me there, this coming weekend, we'll probably try to do a lot more CW. And that's what I got, Rich. Any questions?
Well, a couple of questions. So you just are exchanging the location and the call sign of the other person, is that right? Or
the general format for CW, and if we had voice SSB, would be first you exchange your call signs and you make sure you exchange that properly. Then you exchange signal reports, and then you send an acknowledgement. For the digital, for Q65, that would also include the grid square.
and so then how would you say your signals were off the moon compared to other people? Were you finding yourself to be real strong, or was it still difficult?
It's kind of subjective. My impression this year is we weren't quite as strong, but I think our power output was a little bit less, even though we still should have a good signal. The signal I was hearing coming back, reflecting from the moon, seemed a little weaker, and I just had a more challenging time making CW contacts. But I was also tired, so that may have been a factor. But this year, it's I think the moon was, was a little bit. It wasn't close to perigee either, so that may have been a factor too. It just seemed a little bit weaker this year. Or this past session in last month.
You could look at signal reports from last year and this year and try to compare that, actually.
Well, they're still subjective. We don't quite go off the S meter when we try to do that. But we just, it's more of a qualitative report. And yeah, I think I didn't really look. We only had 7 CW contacts, so that's not really a lot of statistics. Does that help answer your question?
Yeah. Looks like you had fun to me.
Yes, we did. I mean, it still takes my breath away to hear your signal coming back from the moon. You have you're doing something physical with a real astronomical object, and you're really dealing with the speed of light. It's real. It's not just something in a textbook, and that just takes my breath away. It's a good experience. Go ahead,
More
Rich.
questions? More questions for Gary?
So we'll be doing it again this weekend. If you're out in Colorado, you can come out and do it with us, and we'll put a little essay with pictures afterwards on our website, and we'll probably submit a little paragraph to the 432 megahertz and above EME newsletter too.
Please say your call that you use on the contest. Call sign contest.
K0PRT. That's our the DSES call sign, and you could look us up on QRZ.
I'm going to get K3JYD to attempt to get you.
Okay. We'll try to put on our website which band we're on. I think we'll be on 432, but just so you know where to look for us. We're on 432 unless that changes.
All right. All right. Hey, thanks, Gary.
Okay, you're welcome.
And Dan, you got your 23rd pulsar. Did you want to? Could you pull that picture up real quick? Or no? I'm sort of setting you up.
Oh, by the way, I have his report on our website, and I can give you the link in the chat if you want that.
Go ahead, do that. Yeah.
Okay, if that's okay, Dan.
Yeah.
Okay.
So yeah, we tried in August. We have an open house where we invite people from the community to come and visit, and we tried to get new pulsars. Then Rich stayed up all night, and we tried 5 different pulsars, each one going 3 or 4 hours each, and we got nothing. And so we analyzed it, tried to understand, if there's internal noise or just need more time and what it is. But That was on the 437 feed. What we did then was change back to the 1296 feed. And so Glenn Davis and I went down last Tuesday and ran a 3-hour collect and actually got one. So let's see, are you bringing that up, Gary, or is that something I need to find here?
I just put it on the chat.
Oh, okay.
Do you want me to put it share screen or?
Oh, I've got it here. So let me
Okay.
see if I can.
I'll let you.
When you change feeds, how long does it take to change your feed?
A couple hours. Is that showing up now?
Yeah.
So Ray Uberek and AA0L, he's put in kind of a quick change harness up on at the phase center. So it basically takes about half hour or so to take out the old feed, and then a half hour, an hour to put in the new one. For the 1296 or for moon bounce, we also put a transmitter up there. Normally we don't have a transmitter up there, but we do for moon bounce. And then once the feed is up, then we still need time to adjust the receivers, to calibrate the receivers, adjust the gain and all that. So a few hours anyway. Anyway, this is the one I collected. It was B1556-44. It was low on the horizon, so that additional ionosphere may have added some distortion. We also have some internal noise that we're fighting. It just seems like there's RFI everywhere I look anymore, but the pulsars are getting pretty faint that we're chasing too. This is a 37 millijansky pulsar. So it's kind of faint. It's not the best presto plot, but it is does satisfy the criteria. In addition, I run a time series algorithm on it, Riptide, and it clearly showed that we had the pulsar, even though it was weak. So that's just one of the fun things we get to do down there.
When you said it satisfies criteria, does the software tell you that, or do
No.
you see something here?
The software can produce just junk for you, garbage if you're, so you have to look at it. And the criteria are there's 6 different areas of the plot. Like here is this is showing the period and the period derivative rate of change. They should line up. This is a 2-dimensional plot of these two. So you want the dot, you want the cross dot in the middle. You want the dispersion measure certainly to be non-zero. If the dispersion measure is 0, that means you're measuring something right next to you, right in your own yard.
Oh.
So in this case, dispersion measure is 57. We use the pulsar parameters from ATNF, from the database. So we verify that. So the dispersion measure should be 57, and that's where the peak is. So here's a plot of the dispersion measure down here. This is out to 1,000, 1,200, but actually roughly at 57 is where our peak is. So we have a non-zero peak on dispersion. In the frequency and phase plot, you can see a faint trace right here and over here. So this is actually two phases of the pulse. So you can see the phase trace faintly. It's harder to see in the time plot. This is phase versus time. It's harder to see in here, but you definitely see a pulse here, up here on, these are what they call the best profile. So it's, the other one we look for is they use a statistical measure called reduced chi-square to see if you're measuring noise or a real signal. That's what this is, but it also indicates your signal to noise ratio. And when this is steadily increasing, then it's a good sign that you're collecting real data.
Thank you. Yeah, I was noticing the graph at the bottom right on the ones that are really good have a much more pronounced bow tie look to them, I guess.
Oh yeah, they look a lot better. This is above marginal, but it's getting close to marginal. And that's why I use that second algorithm to confirm it. This is the Riptide algorithm here. So I took the same raw data. I run an RFI clean algorithm on it, which basically whitens it to make it white Gaussian background noise. But this is the peak. You can see a faint trace of it here. So this is 1.5 periods of signal. So it's repeated here, but you can see a faint trace. The key thing was the period, it's 257 milliseconds, and then all the digits out here. This was within a microsecond of the period that we had over here. Here the period was 257.0679, and here it's 257.068. So it's very close. That's as close as we can get with, and we're using GPS timing, but that's as close as we can get on our machines. So it's when I use this second algorithm to really help confirm when I have kind of a marginal Presto plot.
That's very nice.
Okay, and I think there's a YouTube video that Dan did with about his riptide data and stuff. So if anyone wants to follow up on that, you can check out the YouTube video. All right. Anybody else have any observations that they did they'd like to share? All right. Any other anything you want to anybody need to present or report on? All right. Well, thank you for joining us. In 2 weeks, we'll have the standard Drake's Lounge. And then a week after that, we're going to have the Australian Drake's Lounge. So got a lot of stuff going on. And don't forget about, if you want to present at the Western Conference, I think David's put sometime in December for call for papers. Start thinking about that. Also, I can always use journal articles for December 12th for the next journal. So, you know, keep up the good work, everybody, and have fun. Okay, that's all I've got. All right. Have a good weekend. All right. Bye.
Thank you, Rich.